Hello everyone, welcome to my YouTube channel Easy Way to Learn. I'm Shailja Tripathi and in today's discussion we will be dealing with displacement reactions. Understand displacement reaction, this activity is performed. In this activity we'll take two test tubes and fill it with copper sulfate solution. Copper sulfate is a blue colored salt, so the solution will be blue colored. See, let's label them as A and B. These are two test tubes. In test tube B, we hang iron nails with the help of thread. And in test tube A, leave it as such. Then after 20 minutes, we'll compare both the test tube. We see that in test tube B, this one, the color has faded. So copper sulfates, that is some copper ions are being replaced in this case, and also the nail that was placed has turned brown. So this was initial iron nail and this is after 20 minutes. So why this has happened, or what is the reason for the reaction? See. Initially it is blue color, now the blue color has faded and it will start turning into greenish. If we leave iron nail for some more time, it will turn greenish. Reason being that iron, which is in the form of nail, is immersed in copper sulfate solution, which is blue colored solution. See, it is blue solution. What happens after 20 minutes? Iron will replace copper from its solution. So we get FeSO4 ferrous sulfate plus copper, which will be deposited on iron nail. That gives a brown finish to the iron nail. This is a ferrous sulfate which is green in color. Ferrous sulfate. So blue color will start disappearing and a greenish shade will start appearing. Okay, the reason for this reaction is to understand, you must remember or you must have studied activity series of metals. So on the basis of activity series, we can explain this reaction. See. See, in the activity series, metals are arranged in this manner: potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, copper, silver, and gold. So as we go down the series, activity of metals decreases. So here activity or reactivity decreases. So activity decreases. Activity of metals decreases. So in this case, we have taken iron and copper sulfate solution. See, iron is above copper in the activity series, hence it will replace copper ions from its solution. So iron is replacing, see, iron will replace, here iron will replace copper from its salt solution. So this metal is, iron is above copper in activity series, hence it will replace the metal which is lower in the activity series from its salt solution. Similarly, we can see some more examples based on, see, again zinc plus copper sulfate. So if we write this reaction, zinc plus copper sulfate CuSO4, what we are getting? Zinc sulfate ZnSO4 plus copper will be deposited on the side of the test tube, inner side of the test tube. See, again zinc is above copper in the activity series, hence it will replace copper from its salt solution. So this is solid, this is aqueous, and this is solid. So whichever metal is above um, in the activity series, it will replace the metal which is lower in the activity series from its salt solution. So the easy way to learn, or you can just remember it in this way, whichever metal is above in the activity series will be more dominant, more powerful. So it will remove the metal which is lower in activity series from its solution. So just imagine the solution is a home where metal with lower activity is residing. So metal with higher activity will replace it or remove it from its home, or just push this copper away. So this is dominant and more powerful, so it will remove the one which is not so powerful. With copper chloride or cupric chloride. See, copper exists as +1 and copper +2. That is, its valency is 1, and in 2 state its valency is 2. So when copper is in +1 state, it is called cuprous. Cuprous, ROUS. And when it is in higher state, it is called cupric. So here we see copper is in +2 state, hence it is called copper chloride or cupric chloride. Okay. Now let's see the reaction. Lead plus CuCl2 will give lead chloride PbCl2 plus copper. Copper will be displaced and it will start depositing. Okay, so this is aqueous salt solution. This is aqueous, lead is solid. So solid lead will replace copper from its aqueous solution and it will form lead chloride aqueous solution, and copper will be removed from the solution and it will start depositing. If the reaction is taking place in a test tube, then you will see deposition of copper on the inner side of the test tube. So you will see a brown deposition here. Okay, if the reaction is given in this manner, often this question is asked. See, if we reverse this reaction and write down, if you are given FeS of ferrous sulfate aqueous solution and we add copper metal to it, pieces of copper, solid copper, what will happen? So you must be again thorough with the activity series. See, metal which is being immersed in this solution is lower than iron. So here no reaction will take place. So you have to be very careful while mentioning with whether reaction will take place or not. So in this case, the metal that we are adding to the salt solution is lower in activity as compared to iron, which is present in aqueous form, aqueous salt solution. So in this case, no reaction will take place. Similarly, if this is the reaction, zinc sulfate aqueous and now I can pick any of the metal which is lower than zinc. Let me take silver. Will the reaction take place? Will silver replace zinc? Answer is no. No reaction. Again, the same reason, silver is lower than zinc in the activity series. So this metal is not as powerful as zinc to replace it from its salt solution. Now let's see double displacement reaction. See, again it is performed with the help of this activity 1.10. See, we take sodium sulfate and barium chloride solutions, and these are colorless solutions. See, we add sodium NaSO4, Na2SO4, sodium sulfate, and dissolve it in water. So we get aqueous solution, and this is colorless or clear solution. In another test tube, you take barium chloride and dissolve it in water. This will make aqueous solution. Again, this is colorless. So initially both the aqueous solutions are colorless. The moment we mix them, we get a white precipitate of barium sulfate, BaSO4. Here BaSO4 will start depositing at the bottom of the test tube after some time, hence it is a precipitate. And we get sodium chloride, NaCl, which will remain in aqueous form, since sodium chloride, which is a common salt, is soluble in water. Hence it remains in aqueous. We can easily balance it. See, twice sodium, so put 2 here. Automatically 2 chloride ions. Here also 2 chlorine atom. Both RHS and LHS side we have 2 chlorine atoms. And barium and sulfur, oxygen, rest all are balanced. See what happens when we add these two aqueous solutions which are soluble in water, we get a white colored precipitate. So precipitate is a substance which is not soluble in water, and after leaving it for some time it will start settling down. So this is called precipitate, and see here it is also mentioned in your book. White precipitate of barium sulfate is formed by the reaction of sulfate ions and barium ions. Any reaction that produces a precipitate is called a precipitation reaction. So this is a double displacement reaction and also a precipitation reaction. See, double displacement reaction basically means, you can understand this from the general formula, the general form of the equation. If we take a salt AB and another salt CD, so what will happen? There will be exchange of ions. So A will combine with D. So we get AD plus CB. So here exchange of ions are taking place. So in this reaction particularly, sulfate ions are displacing chloride ions, or we can say chloride ions are displacing sulfate ions. So when this form of reaction you get, you can write this is a double displacement reaction, because exchange of ions are taking place. See, such a reaction in which there is exchange of ions between the reactant is called double displacement reaction. So this is a very good example of double displacement reaction and also precipitation reaction, where we get a white precipitate. If you recall, we studied in or I mentioned in previous video reaction between lead nitrate and potassium chloride. I'll write it once again. See, reaction between lead nitrate, PbNO3 twice, which was a colorless solution, and potassium iodide, again this is a colorless solution. Both are highly soluble in water. The moment we mix them, we got a yellow precipitate of lead iodide, PbI2, and a yellow precipitate was obtained. And we get potassium nitrate, KNO3. This is again in aqueous form because all potassium salts are soluble in water. So this is also example of precipitation reaction and double displacement reaction. So you have basically two reactions in your book, this one and the one that is previously mentioned in the chapter. Balance this equation also. See, we get twice iodide, so we can put here 2. The moment we put 2, we get 2 potassium. So put 2 here. Again 2 nitrogen we already have, and 6 oxygen on LHS side, and we have 6 oxygen on RHS side. Hence this reaction is balanced. This is already balanced. Hope you understood both the types of reactions well. In the coming video, I'll be taking up oxidation and reduction reactions. So please keep practicing and balancing the equation, writing the equation in correct form. And please like, share and subscribe. Thank you so much.